Wow, are you kidding me? Are you really kidding me? We're finally here at routing. Wow. Okay. Well, um, I guess we could just start getting right into it after I start closing these things down here. And no, I don't want to save changes. And we can close this and keep that up there. We can close this. Disconnect, yes. Close this. And definitely get out of my VMware. My ESXi server that I'm so happy to have. And it's funny because someone was talking about how I need to get another server and to do vMotion and stuff like that, and I'm just like, you know what, I'm just not worrying about that right now. And I'm totally worrying about it right now. It's just like all on my mind since I got ESXi open, set up and everything. I want another server so bad, just because. But anyway, let's talk about routing. So, really, what is a router for? I mean, it's really the purpose of a router. Now, we talk about how we have layer 2 and layer 3, and switches does layer 2 and routing does layer 3. But let's really think about the communication here. Now, if we have this PC, he's going to have a MAC address, and he's going to have an IP. Now, using TCP/IP, you got to have both in order to communicate. All right, you don't have a choice. So if you want to communicate with a device, you got to have a MAC address and a IP address. So coming down here onto this switch here, we'll give him a MAC address of just AAAA and an IP address of 192.168.1.1/24 .1.2. Now, of course, this MAC address is going to be BB. Now, we've gone through this before about communication. We got to build our actual header information by putting in our source MAC, our destination MAC, and our source IP and our destination IP. So this is all good. Now remember, what's really important here is when we're going down the OSI model, we have the transport information, which is going to be layer 4. And then we're going to have, actually, let's look at it this way, because actually our data's sitting here. And we're going to have the application, the session, the presentation, and then we're going to have our layer 4 right here. So starting there, we have our layer 4 information. Then we're going to have our layer 3 information. Then we're going to have our layer 2 information. So this is where our MAC address lies, and this is where our IP addressing lies. So even though we're building a source and destination IP address, it's sitting here. And the only way a PC is really going to pay attention to it is if the destination MAC address in the layer 2 information is for him. Because otherwise, he's just not going to pay attention to it. He's just like, nope, not for me, I drop it. However, if this destination MAC address is for him, or her, whichever way you want to look at it, then I'm going to strip this off and look into the layer 3 information, okay, and see if that destination IP address is for me. Now, keep in mind, this is all great when we're all on the same subnet. However, when we're trying to communicate with someone that is on a different network, and we'll put him on 192.168.20.2, okay, /24, I want you to think about that, because I'm sitting on the same switch all in the same VLAN. Nothing's stopping me here. Now, when that information comes out, he's going to have the layer 3 information sitting here with a destination IP address of 20 and a layer 2 information here. Now, TCP/IP isn't just going to just throw that information down a switch. He's going to look at it and say, well, you know, you're not a part of my network, so I'm sending you to my default gateway. See ya. And where do we get our default gateway from? Where we can statically configure it on our PCs, or we can literally send it to we can literally send it to what is wrong with me? We either statically configure it, or we can get it from a DHCP server. I'm sorry, I'm distracted. Enough said. Okay, so that part's finished. Let's move on. So TCP/IP is not going to just say, okay, let's just send this on the wire, and you know, hopefully BBB gets it or the right person gets it. No, he's going to send it to the default gateway. If it's not configured, TCP/IP says, screw it, I'm dropping it. I'm not even going to send it out. Okay, it's going to be an encapsulation failure. I'm not even going to try to go any farther. Okay. However, if we have a default gateway, think about it. Now, what happens if the default gateway is not in our same network? I mean, let's be honest. Let's think about this. So let's actually bring up a VM here, and I'm actually not going to wait for that to come out because I got VMs actually kind of lingering. I just got VMs already running anyway. They stay running all the time. Alright, we'll just pick on this one here. I need to change all the settings on there, so I don't have to keep going into this. And actually, why am I even doing this? I could just do it right now and save me the hassle. It doesn't take that long. Click, apply, and there we go. So I'm going to go in here and I'm going to say 192.168.1.1/24, and I'm going to say my default gateway is 1. 200, that network. Now, I want you to read this. The default gateway is not on the same network segment that is defined by the IP address and subnet mask. Do you want to save this configuration? Okay. So let's go into here and take a look at IP config. I mean, this is something that's kind of odd. I mean, you're kind of like, I mean, even Windows, I mean, even TCP/IP suite, you know, that Windows has, it's even warning you, like, look, I mean, you have a default gateway that's not even on the same subnet. I mean, really, how can I do this? Really, think about it. Okay? Now, this is something that you can lab to see what the output is and see what happens. But the purpose of a default gateway is to get you out of your network. And the only way to communicate with a device that's within your network, you have to be on the same subnet or the same segment. Okay, so let's look at this. So let's go ahead and erase all this. So here's a PC, okay, and we're going to give it a 192.168.1.1 with a default gateway of 200.200.200.1. And I want you to think about this very, very strongly. Why I'm doing this. 192.168.1.2. I would just say 1.10. Everything is in this broadcast domain with this switch and everything else. Okay? So when I go to build my information and I try to ping something that's outside of my network, it's going to say, okay, send it to the default gateway. 200.200.200.1. So if this goes out, I'm going to have a source destination, a source IP of 192.168.1.1. Now, let's say I'm going to ping a 172 address. So a destination IP of what? Because that's something that you have to understand, because it's going to be the 172.16.0.1 address. It's my MAC addresses that I got to be concerned about. And here we go. Because we're going to say, well, my source MAC is 192.168.1.1. My destination MAC needs to go to whatever the default gateway of 200.200.200.1 is. Oh. Okay. Because based on the information here, layer 2 is going to get us as far as it possibly can within this broadcast domain. He's going to travel as far as he can. The only way he's going to travel any farther past this domain is if layer 3 takes over. Interesting. So my destination MAC is going to have to be for my default gateway, since I'm trying to communicate with someone outside my network. And that's all well and good. So where do I get the MAC address for my default gateway? My ARP table. Well, the ARP table... Okay. What happens here? If I'm going to send it to my default gateway, the issue that I'm going to have is I got to have it in my ARP table. And if I have it in my ARP table, I got to have some type